Hi, welcome to Chem Coach with Coach Powers, where again I am excited to see you have fun learning chemistry, where I want you to enjoy the beauty and wonder of chemistry, and where I want you to grab a little more understanding of some cool chemical concepts. Now, today's going to look a little bit different than some of our other lectures that we've had before, because today I am going to start something new, and this is called a reaction video. Right? So it's gonna be a chemical reaction, and I'm gonna react to it. So you're gonna see my reaction. And it's a video. It's a reaction video. I'm not stuttering. So, I thought it would be fun. I don't know if you're going to like it. I don't know if I'm going to like it. But these are going to be the first times that I've actually seen these videos. And yeah, so hopefully they'll be exciting, and hopefully my reaction will be one that you'll enjoy. I don't know. Let's check it out. All right, here we go. First one, effective surface area on reaction rate. Here we go. All right, what do we got? Got some sort of burning reaction here.
As chemistry teachers, we're all very familiar with demonstrating the effect of surface area on reaction rate.
Oh, good. I like your British accent.
We would do this with marble chips reacting with acid on a top-down balance.
Your flame is a little bit big
However,
there.
what I'm about to show you is an entertaining and quite spectacular alternative.
Excellent. I can't wait to see it.
Milk powder contains carbohydrates and fats, both of which
like
release energy on combustion. Now, if this milk powder is arranged in a small pile...
Set off a fire alarm doing this once. Threw it up in the air.
Then the effective surface area is quite small, meaning that the reaction is very slow.
Fire detector, smoke detector. All right, so small surface area. I've done this before. Look at that thing. It is not really going to do much. It's not going to catch on fire. It's getting burnt, but it's not catching on fire because
However,
it's small
if that
surface
same powder
area.
is sprinkled as a fine cloud, the reaction rate is much faster.
Ooh, the fine cloud.
To do this demonstration,
yes, let's
you
look
should
at
take
the
a
fine
meter
cloud
ruler
now.
and fix a splint to the end of the ruler.
Oh, this is good. I've never done this before. Not like this.
And then arrange this so that the splint can burn horizontally a few centimeters above a protected bench.
Ooh, clamping it
this
down.
is important so that the falling milk powder won't extinguish the flame as it would if you were using a candle.
Non-dairy creamer? That's what we call it.
The height that you sprinkle the powder from will dictate the height of the fireball produced.
Got this little guy.
And you should always take care to step back quickly as soon as the bottom of the cloud ignites.
Okay. Starting to... Whee! Whee! Fire!
Now, if you're feeling brave, you could try sprinkling that from a greater height.
Oh. Get up there, boy! He's up! Oh, my goodness! Watch out! We're all gonna die! We're all gonna die! Oh! That's more than just brave. Run away. Run away. Woohoo! Okay, I would not do that in my classroom. That would definitely cause the fire alarm to go off. That would be bad. Okay, well that was kind of exciting. Good job. I like that final one especially. Royal Society of Chemistry is doing me a solid there, that's for sure. Now, that's actually the site that we get all those little element pictures from. Shh, don't tell anybody. Those element pictures that are up on the wall, I have my chemistry students try to look at, and lately they have not been doing many of them. All right, now we're going to look at temperature. Light stick kinetics, baby. Let's see what this one's all about. Oh, you're going to come over here? All right, we can do that. Ah, Flynn. I like Flynn. Usually not too exciting, but...
A very simple kinetics experiment to show the effect of temperature on a chemical change
George.
Can be accomplished by using light sticks.
George. Totally
light sticks are available at local stores.
I love
and can be found just
George
about anywhere.
Gross, is that what it was?
What I have here are
What do you
3
have here,
beakers
George? 3 beakers,
set
yes.
up.
With 3 light
One
sticks.
with ice cold water, approximately 0
It's
degrees.
chilly in here.
The second, room temperature water, approximately 20 degrees.
Room temperature. Hey, that's the
And the
temperature of the room
third,
right now, right?
hot tap
20
water,
degrees.
which is
All right, it's probably a
approximately
little warmer.
40 degrees.
40 degrees.
I have
That's
light
hot water,
sticks
George. What are you
sitting
doing?
in the water in order to acclimate them
goodness.
so that they adjust to the temperature of the water
Light
bath.
sticks getting acclimated.
What I'm
Okay.
going to do now is I'm going to break each light stick
Don't
so that
break
we
'em.
are able to
Didn't your
see
mother tell you not to
the
break your
effect of
toys?
temperature on this chemical reaction.
Now
You
nobody
may
else will ever be
already
able to play
know
with that again,
light
George.
sticks
That's so rude.
have to be broken so that the reagents
What do you think? Are they going to turn the lights out when we're done?
inside
Yeah, I think
mix.
so. Okay. Yeah, mix it up. Go, George. All right, now the hot one. Be careful, George. That's hot. Ouch! Ouch! Oh! Ow!
and
ow,
shaken
ow.
up so that we have.
Maybe it's not that hot. Okay.
Now, if we dim the lights,
All right. Dim the lights. I told you. Come on.
I'm going to
Dim lights.
wipe the fog off the outside of this one
Mood
so
lighting.
that we can see the intensity.
Excellent.
We notice
excellent.
that the coldest, lowest temperature,
Yes, we do
slowest
notice that,
reaction
George. The
is
one on
in
the
the
left.
ice water bath, and the
Slower
brightest, the most
Not as
vigorous
bright.
chemical reaction is
big
taking
bright
place
on the
in the
right.
warm water.
Warm water.
One
Makes
thing I
sense.
might
More
add here
collisions.
as a precaution, if
reactions.
you're going to do this demonstration in your classroom,
Yes. I
please
should be able
do
to turn
not
off
have the warm water higher than 40 degrees.
Oh, because then I could get
because
burned.
that does affect the chemical reaction to such an
Oh,
extent that
okay.
it destroys the chemicals inside and
All right,
creates a
that's-
problem.
That is a good warning,
So
George.
don't
Thank
try
you.
this higher than 40
Kind of
degrees.
want to try it now, though. 50 degrees. Watch it break. Watch it not work. All right. Well, that was fun. Thank you, George. Thank you, Flynn. Always exciting. All right. Let's go to our next one. And this one is, oh, I already did that one. Concentration. All right. You guys ready for concentration? Here we go. Concentration. Ooh, this guy looks serious. Oh yeah, okay. Dating ourselves in the 90s here. Oh, damn, Dr. Carlson, Zeiss here. All right.
Today we're going to talk about chemical reaction rates, which is
Did not
how
expect
fast
that
chemistry
voice
happens,
coming
how
from that
fast two
body.
molecules might bump into each other and become
How
a new
fast
kind of
two
molecule.
molecules might
And there's a
bump
lot of
into each
different
other.
things that can affect how fast chemistry happens.
Yes, this is
Today
true.
we're just going to focus on
Thank you,
concentration.
Dr.
And to
Carlson.
do that, we're
Ridiculous
going to use
first
an
names.
old standby chemical
Simon,
demonstration
maybe.
called elephant toothpaste.
Ah,
what I have here
elephant
is some
toothpaste. All right, you guys
hydrogen
like this.
peroxide and some
If we
sodium
ever
iodide,
get
which
to
is
be
kind of a
back
salt
together
kind of thing.
again,
Mix the two,
let's
and this
do
should
this one.
create a lot of
What's
bubbles
gonna
of
happen?
oxygen over here, and it'll foam up and be all really cool
All right,
and
so we
exciting
got
and be
hydrogen
wicked
peroxide.
fast. All right?
I'm
Here
ready.
goes nothing.
His hair is green. I love it. And it's a flat top. I love flat tops. All
Oh
right.
yeah, look, there it is. It's bubbling.
It's
Ooh,
bubbling.
bubbling away.
Go,
Now this is
Carlson.
3% hydrogen peroxide.
No, not
what you could buy at
3%.
the store if you want to clean out a cut or something like that. Be careful with hydrogen peroxide because it gives
it's
off
going so
oxygen gas.
fast.
So you can see here it
Stop
goes.
it.
It's
It's
still
too
bubbling
exciting.
off. Oxygen gas is coming
my
out in a little
goodness.
foam. And I put a little bit of
right. He's gonna
soap
do
in there, dish
30%
soap,
next.
and that's
He's
going
got
to make
it,
this
right?
cool little
Let's look at
foam.
this video.
And it's still going. So pretty
yeah.
cool.
Oh yeah, this is a 4-minute
And
video. Next time he's
we
doing
just may
30%.
have to put this on stop time.
Yeah, this one is boring.
And remember, this is 3%.
Yes,
3%
you just told us
hydrogen
that.
peroxide.
Green
It's still
flat
foaming,
top hair.
and it's
glasses.
going to make a mess now. There it
This guy
goes.
is- this is, oh, it's oh, mess. He is working up
Class.
the slow thing though.
Maybe I'll go. Oh, here, look. You can see it filming over the side, huh? Beautiful.
Yeah. Okay, he's working up the slow stuff.
3%
so we can
now.
Get a little more engagement out of the fast stuff. Come
Yeah.
on, just go ahead and go to it, Carlson. Come on, we're waiting for it.
Still going.
Yeah, I know. We're
So
bored.
this is a reaction rate, right? The more hydrogen
See, look,
peroxide
he's
that's in there,
tying-
the
he's
faster
tying
this
it
should
into
happen.
the concept.
That's one of the things about concentration.
Concentration.
The more
3%,
of a substance, the more concentrated a
30%.
substance, not just
Love
how
it.
much it is, but more concentrated, the more likelihood that two molecules will collide and
You
then
get me. You
have
got
a
my
reaction
boredom?
happen. So in this case,
Tied
the
me right
salt
into it.
and the hydrogen
Didn't even see that
hydrogen
coming.
peroxide molecules will collide, and then you get a reaction happen. And the more likely they are to collide, the faster the reaction will happen. And since we have we have less concentrated hydrogen peroxide in here right now, it doesn't happen very fast.
No. Okay,
Well,
let's go.
This
Speed
is
it up.
still moving kind of slowly.
Higher concentration. Let's go,
Very
Carlson.
slowly. So we're going to clean this up, and let's try it
There's not
with
much to clean up there.
30% hydrogen
Thank
peroxide.
you. All right, here we go. All right.
30% hydrogen peroxide is much more concentrated, so it shall
There
happen
we
faster.
go.
There it is.
That's
Nice and
better.
fast. Look at how fast it's
Yeah,
happening.
that's
That's
what we
because chemistry happens faster because there are more molecules present to collide with each other to cause the chemistry to happen. And when this reaction happens, it causes bubbles. So we get lots of bubbles when it happens fast.
That's my
So
bubbles.
30%. It happens really
Bubbles.
fast.
How would you
Now
do
let's
your
just
motion
quick
bubbles?
back it up and just compare one more time the 3% to the 30%.
No, don't back it up.
So going
No,
back in
I don't wanna
time,
see it again. Oh,
Zoom it
okay.
right on back.
Backwards is kind of cool though. I just
and we
don't need
start
to see
off
the 3%
with the
again.
3% hydrogen peroxide.
No, 3%.
And you can see that there's not
Fall
very many
asleep.
molecules. Well, you can't see that, but it's moving very slowly because the collisions happen
We're not interested in
slower. They don't
3%.
collide as often to cause the chemistry
My
to happen.
paint is
And
drying.
then if we kick it up a notch to
Watch the paint
30%
dry. I've seen
hydrogen
that
peroxide,
All right, kick it up. Kick it
the
up, baby.
chemistry happens
30%.
much faster. Boom. There it goes. So we've learned today that the more
Alright. Love
concentrated
it.
your chemicals, the faster your chemical reactions will happen.
Yes, we have learned
And
that.
as an added
Thank you,
bonus,
Carlson.
the more concentrated your chemicals, the more impressive the chemical reaction.
Yes.
Of course, it's the more dangerous chemical reaction too, depending on what your chemicals are. It's not the amount of chemicals you have, but
Not
the
the amount.
concentration that will determine
Concentration.
how fast the reaction happens.
It's the tie-in between Matt Carlson, not Simon. Sorry, got it wrong. All right, a little elephant's toothpaste. We already saw one of those. All right, here we go. Last one, final one, the catalyst. Yes, here we go. All right, what do we got? Decomposition. Okay, hydrogen peroxide decomposition. Let's see what we got going here. He's playing. This is so exciting. It's going already. All right, let's decompose the
This
hydrogen
demonstration
peroxide.
is a fun way of showing the effect of different catalysts on the rate of decomposition of hydrogen peroxide. Before moving on to the demonstration, it is important to
we've got
establish
one
for
of
the
the British.
students that hydrogen
this is from the
peroxide is
Royal
indeed
Society of
decomposing all the
Chemistry
time.
again.
Otherwise, the students may confuse reactants with catalysts. One possible way of doing this
not
is
confuse
to
that.
show that the bottle of hydrogen peroxide is vented to allow oxygen to escape.
We don't have those in America. We have those accordion bottles. We're just
Another
gonna let
way
them
is by
expand.
pointing out that the hydrogen peroxide is stored in a refrigerator and that it has a finite lifetime.
An ice
Line up
box.
6 large cylinders
Six
and add
large.
catalyst to them as
Large.
follows.
It's a
Half a
large.
gram
It's
of
like
manganese
a place where you go
dioxide,
Stay.
half a gram of lead dioxide,
All right, manganese
half a
dioxide,
gram
lead
of iron
dioxide,
oxide,
iron.
a small amount of
3.
chopped potato, a small amount of chopped liver, and a small amount of chopped boiled liver.
Chopped liver.
It needs to be boiled in water for about
boiled
5
liver.
minutes. To
What
each
was
of
in that
these,
middle one?
add
I
1
don't know.
centimetre cubed
1 centimeter cubed. How about let's call it
of
a
washing up
milliliter?
liquid. It doesn't need to be measured accurately, but you
No.
need to use the same amount each time to ensure
Okay.
that it's a fair test.
Fair test.
Avoid spilling the
This
washing
is
up
the
liquid down the sides
soap.
of the tube.
What is that? I don't know what that is. I didn't hear it.
And
I was
indeed the
talking.
catalyst also needs to be at the
Okay.
bottom of the tube
Yes. Chopped liver? What am I? Chopped liver?
and not down the sides.
No, you're boiled chopped liver. Ooh, that looks gross. I hate liver and onions.
Then
It's like one of my
simultaneously add
least
25
favorite meals in the
centimetres
world.
cubed of
cried
75
once
vol
when my mom
hydrogen
wanted me to eat
peroxide to
liver and
each of the
onions.
cylinders.
She didn't make me eat it. If I'd known all along that I could cry to get out of eating it, I would have tried that a long time ago. Oh, it's so exciting. Look, I have my 2 partners. They're helping me. By the way, you are
The
figuring
foam
that
will
this
rise
is
up the cylinders at widely differing
elephant toothpaste
rates.
again, right? You figured that out already. Ooh, that one's kind of staying together. What did you do? What kind of soap did you use? It's not very liquidy. And what is that?
The foam is formed from oxygen, which is produced by the decomposition
Foam
of
is
the
formed
peroxide.
From
The
oxygen
rates at
and
which
soap?
they rise up the cylinders give a graphic comparison
Cylinders,
of the
graphic
differing
comparison.
effectiveness of the catalysts.
The iron
The order is normally
preoxide
lead
was not doing much
dioxide,
at all.
manganese dioxide,
Manganese did a
fresh
lot.
liver, potato, iron oxide, and then
Potato,
boiled
that's what it
liver.
was.
But this may be affected by the surface area of the powders. Liver contains a peroxidase enzyme, which is denatured by boiling it.
Uh-huh. Ooh, okay, it's got oxygen in it, so it should light up again.
It is usually possible to light a glowing splint in the foam, although sometimes this fails if there's too much water in the foam.
Maybe that's why she didn't want too much water. All right.
This demonstration can lead to plenty of discussion and possible further experimentation.
Oh, okay.
Is it in fact a fair test?
Is it?
Should we be measuring the number of moles of each of the catalysts rather than the number of grams?
Should we?
How much of the potato and liver is actually enzyme? Are the surface areas of the powders comparable?
Surface area. That makes a difference, right? Oh my goodness, she was just giving us hypothetical questions. Ones that she wanted us to answer on our own without telling us answers. What's that all about? Let's hear
How
it
much
again.
of the potato and liver?
Potato. I love
Should
it.
we
She
be
says
measuring
potato.
the number of...
Okay, here we go. Listen, stop talking, Towers.
This demonstration can lead to plenty of discussion and possible further experimentation. Is it in fact a fair test?
No,
Should we be measuring the number of moles of each of the catalysts rather than the number of grams? How much of the potato and liver is actually enzyme? Are the surface areas of the powders comparable?
I got distracted when you said potato, and I didn't hear what you said after that.
Are the surface areas of the powders comparable?
That would be a good question. Let's go back to the
rather
potato.
Than the number of grams.
Yeah.
How much of the potato and liver is actually enzyme?
How much
Are the
potato
surface areas
and liver
of the powders
actually
comparable?
Enzyme. Now I'm getting you. All right. I don't know. I just got really distracted every time she said potato. It just sounded cool. What can I say? All right. Well, wow. We've done our reaction videos, and yeah, I think that was kind of fun. I'll bring it back around to a little PowerPoint. We can talk about some of the stuff that they talked about, but hopefully you enjoyed watching me watch them. Why is that even a thing? I don't know, but it's a thing, so let's just go with it, right? Don't fight it. I am Chem Coach Powers, and this is Chem Coach, and you're learning chemistry, and it's awesome.